I've worked in industry, many different places, and so everything I've seen in industry, I've brought back into the classroom. It's always great to see it early before people. I call the classroom sort of a sandbox, and then once they go out into industry, that's a very sharp learning curve. So the earlier everybody has these experiences, the better. So in this talk, we're going to look at case studies in 4 different arenas, two in the master's program, 2 in the undergraduates, of MITRE's CAPEC role in threat management, specifically here at St. John's out in Queens University in New York City. That's great. So yeah, a link to our master's degree program. So we have a master's in science and cyber and information security. The full curriculum's here. Everything's continually, it's an organic system. These classes are organic, so we keep improving them. We have improvement processes and things. So, but these are our current lists. You can see the different tracks: cybersecurity, data science, and analytics, as well as IT are some of the specific focuses inside of our master's degree. So thank you. Next slide, please. Great. So again, we're going to look at both the Masters of Science in Cyber and Information Security, specifically our pen testing and ethical hacking course, which is CYB 715, as well as our Principles of Secure Scripting and Cryptography, which is CYB 625, and 2 bachelors. We're going to call out 2 bachelor's classes, Bachelor in Science, our Secure Software Development, which is 1035, and then our Network Security, 2 network security courses, 1012 and 1011. So and again, so we're going to start off with the pen testing, which you'll hear we have very similar points as Phil and Max and Navitine mentioned earlier. So please, next slide. Great. So we really focus on pen testing from what we've seen in industry. And a lot of times, as we heard earlier, pen test reports turn into basically risk assessments. Risk assessments, there's actually a lot of different federal, state, specifically federal laws, right, that require risk assessments. They don't specifically, as we're hearing, lay out the exact organization of risk assessments, right, and for good and for bad. The good part is every organization can figure out what threats and what are the pain points for their organization. But again, the bad side, you can have 2 organizations across the street in the exact same sector, and pen test reports and the way we describe risk can be entirely different. So and how do you even pick up the phone and have a conversation if everything's not standardized at some level? So I put in a screenshot here of the NIST Special Publication 800-30 Guide to Conducting Risk Assessments, right? And again, they don't really tell you how to take this visualization and turn it into sort of a 2-dimensional report, as we heard a nice repositories up on GitHub, right? And so every organization probably has developed something internally for themselves. And this visualization, again, you look for your threat source, you figure out what your threat event is, potentially the vulnerabilities, and then you have your impact, what are you actually impacting if this thing goes down, and how severe is that? And then out comes the risk of each of these events. And then your overall risk, which is, again, another debate, if you have 3 highs and, 100 lows, where does that fit? Or if you have 1,000 lows, is that equivalent to a high, right? So there's a lot of different debates that are internal to a lot of organizations. There's a couple different risk models. You have the FAIR Institute, you have the NIST model as well. One of the papers I just published a few years ago was, again, reiterating what Phil and Max were saying earlier, right, is specifically, I think it depends too if you have internal pen testers versus external pen testers. But one thing I was finding is that no 2 pen testers would write up findings the same way, similar to everybody else. And so now if you, for legal reasons, have to say how many of this you have and how many of that you have, now suddenly you have an NLP problem, trying to figure out, do I, the way they've written up things can be the same problem, just written differently. And now you're down a whole wonderful, you know, research problem for NLP if you choose to use NLP. So yeah, so I gave an example here, and I posted that to the community, especially for healthcare side, because you're under HIPAA, which requires you know, risk assessments. So thank you. So as we can see, again, here's the NIST 800-30 guide for conducting risk assessments. They clearly have mentioned, they gave examples of threat, you know, they provide representative examples of adversarial and non-adversarial threat events at a level of detail that can be used for risk assessments. And they cite CAPEC as a great source for actually, you know, going into depth into these different threat events. Excellent. And so as we heard earlier, one of the things I have the students do is build risk assessment reports as we pen test. So that one of the things they do is we specifically right now are following CompTIA models so that students have certifications when they finish different programs, undergraduate and graduate. So right now we've structured it around the ethical hacker exam as well as the CompTIA Pen Test Plus. But as they work on these different areas of pen testing, we specifically have them build a report. It's up to them. Again, I'm going to have to direct them now out to the GitHub, right? But I want them to get familiar with how to write up these risks that they find through the pen testing. And one of the things we can see is bringing in the CAPEC as well as the NIST controls. Again, for these reasons of having a larger picture of all of the potential threats that are out there, and understanding the bigger picture. Because as we said, you know, you can have all of the cameras on one door and leave the side door wide open. So that conscious effort to make sure that we've connected it to the larger system, you know, is essential as we get to be more and more online down the line. So then I'd like to also talk about our secure scripting course. This is a different graduate level course, specifically towards scripting. It does talk about cryptography. It's again in the master's degree program. So one of the key deliverables at the very end of the course is a research paper applying to secure scripting. And it kind of goes back to some of my earlier work I did with Professor Aho and Professor Yang back in 2015, when we were starting to look at static analysis techniques and trying to come up with sort of a meta solutions to all of these problems. And so one of the things we did was map it to CAPEC so that we were looking at malware and we could see major gaps. So a lot of the research at the time didn't put it into the larger framework, right? So I have the students do that again in the secure scripting course. I'll explain some of the different frameworks we look at. So again, it's up to them. It's their research. I mentor them, right? But some of the things they can look at are the CVE, the NVD, CAPEC, NIST 800-30, and the wonderful NIST bugs framework, which was developed a few years ago, that really gets at the essence of our bugs. So again, for the undergraduate course, secure software development, again, we have students work on building their own software, and every week we work on a new lab to secure it. A recent paper came out kind of describing the whole process, so feel free to go back and look at that. One of the things I'm asking students to do going forward is to connect all of these findings and vulnerabilities to these larger frameworks at the end in their final report. Another thing, I know it's not CAPEC, it's the CVE, it's MITRE, but we do have students, you know, become familiar with the CV. I put an example up here for the recent Log4j problems. We have, in our course, we look at Java, Python, PowerShell in our course. And so they kind of get the feel of these different languages and how they interrelate a little bit. And then our final courses are our network security courses, which is CSS 1011 and 1012. Great. So again, you know, they have a lot of labs all semester. One of the things I ask them to do on the final project are building these larger pictures for a sector that they want to go into. And so one of the things we're having them do coming forward is again connecting the findings from the labs and telling their story and interconnecting it to this larger picture that these wonderful ontologies provide for us. And please, yeah, here's our references. of all of the amazing work that we build on. So thank you.
Thank you very much, Suzanne. Um, okay, now we're going to move on to Akand Rahman, and he's from Texas. Sorry, oh boy, Tennessee. Sorry about that.
Well,
Tennessee Tech University. So take it away, Akand.
thank you so much. Greetings, everybody. I'm Akan Raman, and I'm a professor at Tennessee Tech University. And today I will be discussing my experiences on how I integrated CAPEC-based static analysis exercises in my course called Secure Software Development. So when I started in fall 2019 in my current institution, I noticed that there is a lack of courses related to cybersecurity and software engineering. And I realized that now that we have this big push related to securing, developing a workforce who are well equipped with cybersecurity knowledge. So there are, if you do a quick Google search, then you will find a lot of statistics on how there is a White House executive order on improving the nation's cybersecurity. And when it comes to Europe, there is this gap of where there are more than 350,000 job openings related to cybersecurity, but there is not enough talent to fill that in. So this all of this got me motivated to propose a course related to secure software development. And one of the big parts of that secure software development course was teaching students to talk about secure, to learn about security static analysis. And I felt that as I'm somewhat affiliated with CAPEC, I felt that the CAPEC is such a great knowledge base. I can build on top of that to design my security static analysis. So the work that I'm presenting today, it is about how students feel about CAPEC-based security static analysis exercises. Some of this work has been published as a peer-reviewed publication at FIE, and this work is partially funded by the U.S. National Science Foundation. So I was going over the CAPEC resources, and there's a lot. And in particular, I was interested to find out if there is a nice mapping between the attack domains proposed by CAPEC and the corresponding security weaknesses. So the idea here is that the security static analysis exercises will be developed in such a manner so that students will learn about the known security weaknesses. And if the known security weaknesses can be mapped to an existing attack domain, such as something like adversary in the middle, then students will be motivated to know about these weaknesses and also proactively detect them and mitigate them when they develop their source code. So in my exercises, I identify the following security weaknesses, namely use of HTTP without TLS, use of weak cryptography algorithms, hard-coded secrets, admin by default, and invalid IP address binding, which respectively can be mapped to the following CAPEC attack domains, namely adversary in the middle, software integrity attack, authentication abuse, privilege escalation, and flooding. So with this mapping, my goal was to make students become very aware about that. Not only these are known weaknesses, these things should be taken care of very well, especially when you're writing source code, because all of these weaknesses have a direct mapping to the attacks. So altogether, I developed a few exercises. Not all of them were related to security static analysis. Some of them were related to fuzzing. Some of them were related to logging, forensics. Some of them were related to requirements engineering. But in this particular talk, I'll be focusing more on the exercises that are related to static analysis. To give you an overview about this course, it was a graduate level course, first time introduced in fall 2020. It was 14-week semester course, and it didn't because our graduate program is small, is on the smaller side. It didn't have a big enrollment, so it was a 12 student course. Um, uh, in this particular talk, I'll be focusing on two types of exercises. One is Git hooks for automated security static analysis. So how can you automate the whole security scanning process using Git hooks, which is an utility provided by the Git version control system. And then the other exercise was focused on security weaknesses. So how now that we know these known security weaknesses exist, how can we build a mini scanner to find these security weaknesses automatically? So once these exercises were discussed in class in the lecture, then then the students were asked to perform these exercises as part of their course requirements. So to understand the perceptions, I did two things. One is related to survey. So one is related to performing a survey, and the other one is looking at their grade books. Then from there, I did a qualitative analysis, and from there, I answered two research questions. Research question one was their performance, related to performance, and the research question two was related to the positive and negative perceptions. So the positive there. So not from our analysis, what we found out is they're both positive and negative perceptions. One is so the positive perceptions related to these security static analysis exercises were lecture reinforcement. So students reported that when they were asked to perform these exercises as part of their course, it made them more aware about the lecture materials. It made them more aware about what was taught in the class. So it helped them to actually think through what they learned in the classes. The second positive perception was practicality. So all of the exercises that were performed, they were mined from open source repositories. So when I presented examples in the class, they were actually from open source repositories. And then when I asked them to apply their knowledge that learned from their class into some existing open source repository, the students felt motivated to do these exercises because they felt that this is more practical. They're doing some practical work which has a connection to the real world. The third positive perception was related to sense of accomplishment. So with security static analysis exercises, which are CAPEC based, help them to gain confidence in the sense that they realize that after completing these exercises, they realize that they were able to do something tangible, which might help later on do something feasible when they enter the workforce. And then also skill set development. So students agreed that it helped them to develop their skills. Before coming into the class, many of the students were not familiar on how to build a mini level static analysis tool from scratch, how to work with parse trees, with ASTs. Many of them were not familiar with CWEs, common weakness enumeration, and also the CW database, and also CAPEC itself. So it helped them to increase their cybersecurity knowledge, even though some of the students did in fact come from a cybersecurity background. All of these perceptions actually help students. Shows that these exercises to some extent help develop the students' knowledge. But there were some negative perception as well. So introducing these types of classes comes with some level of overhead, and one of them was artifact management. So for to disseminating the resources that they need, for example, the right computing environment, the right software dependencies, the data sets themselves, all of that was managed through a Docker image. And because they were asked to apply these exercises on real world data sets, that meant that they had to actually like work with a real data set which was shared with a Docker image, which is a Docker in this case is Docker is a popular container technology that you can use to share your resources. When it comes to artifact management, there were some negative perceptions from the students. So they said that working with Docker images on getting the source code artifacts, downloading them every time took time, and it was somewhat of a barrier. Another negative perception was in some cases the students mentioned that they did face a lot of some barriers when it comes to lack of background, especially when it comes to static analysis. It usually involves good knowledge about how abstract syntax tree works, parse tree works, how we can use some level of recursion to find out the patterns that you want to identify, do some information flow analysis and things like that. So yeah, because of the lacking in the existing undergraduate curriculum, the students felt that that was a barrier to do even better in these particular exercises. So the implications of both of these perceptions, positive and negative perceptions, is that it's not a silver bullet. So if introducing CAPEC-based static analysis exercise in the classroom is always a great thing to pursue as an educator, but We need to be, while it is positively perceived by students, as they have as documented in our paper, it comes with some level of overhead and with some level of negative perceptions. So I'm still, as an educator, I'm still start struggling to understand if how can we do better artifact management. If I want to share data sets with the students, can I do use another type of technology? Can I use something like a Google Drive? Could that be better? And then the lack of background, it actually corresponds to a bigger issue, maybe related to CS knowledge in general. In our part, in our institution's curriculum, things like information flow analysis, program analysis, and compilers have not been covered very exhaustively, and that creates a barrier when you are trying to do security static analysis exercises. So in all, it was a great experience that I was able to introduce these exercises, which are built on CAPEX attack patterns. But while doing so, while they were the perceptions were mostly positive, there were also some negative perceptions that we as a community can learn and can navigate through. Yeah, so to conclude my overall summary of this presentation is that I discussed why what was the motivation of introducing secure software development course in this in our curriculum at the graduate level. Number one. Number two is that how I actually systematically used CAPEX attack patterns and build a set of static analysis exercises. And then the third part of my talk was how I systematically identified positive perceptions and negative perceptions. The existence of positive perceptions and negative perceptions showed that while this is a great goal or this is a good task to achieve in any curriculum or on introducing CAPEC-based exercises, it does provide some challenges. The challenges in my case include for my class in that I took in fall 2020. One was related to artifact management. One was related to lack of background. With moving forward as a community, we can think about how we can better manage artifacts when we are trying to introduce secret software development exercises in our classrooms, and how we can, as CS educators, in total, what can we do to eliminate the lack of background when students do face when they are navigating to working with secret static analysis exercises. So with that, I conclude my presentation. If you have any questions, please reach out to me via email or Twitter. The paper that I mentioned was published at the Frontiers in Education Conference, FIE, in 2021. The preprint of this paper is available on my website. We did a larger extensive study related to on us introducing secure software development as a course in our curriculum, and we published that findings in the Quadic Conference in 2021. So with that, I conclude my presentation, and I will open up the floor for any questions before we go to break.
Hi, thank you, Akand. If you have a question, you can raise your hand and I will call on you. There were some questions in the chat. Justin Murphy.
Yes, Dr. Rahman, very good to see you. Justin Murphy here.
Hello, Justin. I can fill in a little bit. So Justin Murphy was my advisee. He was my master student. It's so great to see him in this forum.
I'd love to hear your opinion, both through your experience teaching the course, this course and other courses, through your research. You can, through the using of static analysis tools, you can teach anyone to find a vulnerability. But could you also speak to the importance of not only identifying, hey, there are vulnerabilities in my software, but also the importance of understanding, especially for these students, as they eventually are going into the cybersecurity workforce, how these vulnerabilities are being exploited, and how that relates to the importance of educating secure coding practices along with using these types of tools.
Yeah, I think thanks for the question. I think what we educators we can do what I do, and I think my students can relate to, is that I tend to try them. So obviously the CAPEC attack domain is a good starting point. It actually showcases the fact that we do in fact need to care about these things, because industry folks really care about these things, and that is why they have come up with this knowledge base. Another quick way to disseminate all these things is that if you can connect something related to static analysis with some real world breach. So in this particular course, when I was teaching about static analysis and using static analysis to find security misconfigurations, I did bring up the Capital One data breach. So I think that resonated with many of the students on how and why static analysis is important and how it can be done to detect it. But there might be other ways around. In the education community, there is something called authentic learning. So authentic learning is education philosophy, which is perceived to help students to learn about cybersecurity. So that is something that moving forward, I'm planning to integrate in my classroom so that the students are even better informed on the importance of security static analysis.
Yeah, thank you for that. Looks like we're over time. So if people have questions, you can post them in the chat room and maybe the speakers can respond to them during the break. And I really appreciate the speakers' presentations. It was great to have you and looking forward to working with you.